Hello everyone, I am Rajkumar Nenawat and welcome to my channel RK Study Circle IIT. In this lecture, I'll be going to discuss a topic named functions and relations, in which I am going to discuss introduction to functions, introduction to functions, the second one, types of functions, types of functions, and the third one is domain and domain and range of a function, domain and range of a function. And we have the concept named as functional equations, functional equations along with graph graph transformations, else graphical transformations. In fact, the last two topics might be to teach last two topics. It might take very long time. So I'm just planning to complete the first three topics in this video session. When it comes to the introduction to the functions, let me go with the basics. Like, let's say, for example, I'm taking f of x equal to sum x plus 2, x plus 2, and let me consider a set of values for which the x is going to satisfy, let's say 1 2 3, let's say 1 2 3, and the f of x for x equal to 1 2 3 I am going to get based on this functional value. That is, when I keep x equal to 1, it is f of 1 comma x equal to 2 means f of 2, x equal to 3 in the sense f of 3. So my f of x values are going to be f of 1 in the sense 3, and then f of 2 equal to 4, and f of 3 equal to 5, f of 3 equal to 5. Let me consider the this entire set is are the values of set A, is are the values of set A, and these are the output values are the values of set B, 3 comma 4 comma 5. And here comes the pictorial representation of two sets, where I can say set A as this one, set A as set of input values, and I can say set B as set of output values. And even the one more name of set A, I can write set of pre-image, set of pre-image, and set B I can write is as set of image, set of image. At the same time, I can even say set A as domain values, domain values, or domain values, or domain set, or domain set. Here I can say codomain values, codomain values, or I can even say it as codomain set. Here I'm saying set A as set of input values and set B as set of output values. These two sets are related, connected with the relation f of x equal to x plus 2, f of x equal to x plus 2. Let's say for the same set of input values, if I change its relation, if I change the relation between set A and set B, the relation was maintained with f of x. Let's say I'm writing f of x equal to x square plus 2. For the same set of input values, when x equal to 1, I'm substituting f of 1, I'm getting it is equal to 3. When x equal to 2, I'm getting its value equal to output value equal to 6. And when x value equal to 3, I'm getting the output value based on its relation is 11, right? So previously the given relation was linear relationship, that is f of x equal to x plus 2. This one was linear linear relation. And here I'm writing at present f of x is x square plus 2, which was I'm writing it as quadratic quadratic relation, right? So it all depends on, even though we are supposed to make a note, like even though the inputs are same, the input values are same, output output is dependent on given given relation, that the relation is given in terms of f of x. The relation is given in terms of f of x. So for example, I'm writing any expression f of x equal to let's say f of x equal to a naught x power n a1 x power n minus 1 and so on. The function could be anything. The function could be anything. From this function, I'm writing from this expression, x is nothing but the variable. Other than x, all the rest of the things are constants, and I'm writing f of x as the function in terms of variable. Function in terms of variable. In fact, the variable is nothing but the values takes from set of inputs. I can write set of input values, set of input values, and I can write f of x is the set of output values, right? And I can even write x is nothing but independent variable variable. When I am replacing f of x equal to y, then y is said to be the dependent variable. So until unless you give the input value, you don't get the output value. Until unless you give the input, that is x values, definitely we are not going to get any values as output. So y is purely dependent on x. Y is dependent on x. Dependent on x. Yes. And in general, if I wanted to write, the output value is dependent on input values and given functional relation as well. So let me mention, the set A is consisting of x1, x2 and so on xn values as inputs, and set B is consisting of the number of elements as y1, y2 and so on yn and so on yn. And here let x be belonging to A, which is representing the every value which is in a set A, and let y be any value which is lying in set B, which we generally call it as the output. So from the map here, I can say the function f is mapping from A to B. The function f is mapping from A to B, and it means since x is the input value, I have to give its input so that I have to get its corresponding output. Here the x is belongs to the set A and the y value is belongs to the set B. So my functional equation I'm supposed to write like this: f of x equal to y. This is what the actual mean of set. Let's go with an example. Let a set of input and the set of output values are given by A is a set in which x, where x is multiple of 3 up to 20, and B is a set in which 2a minus 1 is the observation where a is the prime number up to 20. Then we are supposed to find out the first question A union B, the second question A intersection B, and the third question is A dash B, A dash B. So for solution, first of all, let me define the set A first. Set A, A is the multiple of 3 up to 20, means I can write 3, 6, 9, 3, 6, 9, 12, 15, 18. That's it. And let me define set B, where the first prime number is 2. 2 into 2 minus 1, its value is going to be 3. And the next prime number is 3. And 2 times of 3 minus 1 in the sense, it's 5. The next value is A. The prime numbers are 2, 3, 5, 7. Then 11, 13, 17, and 19. Up to 20, it's 19. So when a equal to 3, I have written it's 2a minus 1 is 5. At a equal to 5, I could write 2a minus 1, it is equal to 11. At a equal to 7, I can write 14 minus 1, it's equal to 13. A equal to 11 means 22 minus 1, that's 21. A equal to 13, in the sense 26 minus 1, it is 25, right? And 17 into 2, that's 34. 34 minus 1, it's 33. It's 33. And 38 minus 1, it's going to be 37. So first of all, the case 1, the question 1, I am supposed to find out A union B. A union B in the sense, I can write down 3, 5, 6, 9, 11, 12, 13, 15, 18, 21, 25, 33, and 37. 33 and 37. That's the first one. And the second one comes out to be A intersection B. A intersection B means I have to consider only the common values. Only the common values. What are those common values? 3, comma 3 is only the common value for set A and set B. The third one is given by A minus B or A dash B, means I have to cancel out the values which are common in set A and set B. At the same time, I need to write the elements of set A only. Rest of the values are from set A are 6, 9, 12, 15, 18. So this is the set of values which are representing A minus B, right? When it comes to the types of functions, the functions are can be of many types, namely 1 function, 1 function. This 1 function is even also known to be injective function. Injective function, right? The second one is many one function, many to one function. Let's say the third one is said to be the onto function, onto function, or the same onto function is also named as surjective function, surjective function. And the fourth one is going to be injective function, injective function. We will going to learn all these functions in detail. And fifth one, let's say the bijective functions, the bijective function. Sixth one could be an algebraic function, algebraic functions, namely the first one, polynomial function, polynomial functions and quadratic functions. Then we have trigonometric functions. The functions which are involving the trigonometric ratios are told to be the trigonometric functions. And the eighth one is inverse trigonometric functions. Then logarithmic functions. The next one comes out to be the exponential functions. And on the 11th position, let me give some special functions. What are those special functions? Particularly as greatest integer function. The second one, fraction part function. The third one, modulus of a function. And the next one is going to be the signum function. The 12th one, even function. 13th one, odd function. The 14th one, periodic functions. And the last one is most important one, that is the composite function or the combination of functions. Now we will discuss the types of functions in detail right now. Here the definition of one function comes out to be the mapping of a single image in output set will have only one pre-image in input set. Then the relation or the function mapping from A to B I mean domain to codomain is said to be, the relation or the function is said to be a one function. For example, one value of input is having only one solution. Let's say f of x is equal to x square plus 2. So I'm writing its value equals to be 3 and then 6 and then 11. Here let's say B is the set of images and 3 is the image with respect to the pre-image 1 and 6 is the image of 2 with respect to the given relation f of x equal to x square plus 2, and 11 is the image of the value in set A, that is 3. And since there is only 1 to 1 mapping, 1 to 1 mapping, we call the function as 1 1 function, 1 1 function, right? The definition of many one function is given: the mapping of image images in in set B are having more than one one pre-image in set A. Such functions mapping from A to B is or are said to be are such functions are said to be the many one functions. The many one functions. For example, I have domain and I have codomain. Like, let me take -2, -1, 0, 1 and 2, and the relation is given between set A and set B was f of x equal to x square minus 1. So when you substitute x equal to -2, I'm getting that value equal to b, that is equal to 3. And when I'm substituting x value equal to -1, I'm getting 0. And when I put x equal to 0, f of 0, it is -1, and then it is 0 and again 3. And while writing a set, we don't repeat the values. In the sense, let me write the inputs: -1, -2, 0, +1 and +2. Here the output values are only -1, 0 and 3. Here the mapping comes out to be, here is the f of x, and the mapping is getting to be, when I'm substituting -2, I'm getting 3. The result is 3. This is my mapping from A to B. And when I'm substituting -1, I'm getting the result 0, and for 0 I'm getting the result, it is equal to -1. For the +1 I'm getting 0. For the +2 I'm getting I'm getting 3. So for the same image in set B, I'm having two pre-images in set A, that is -2 and +2. So for the same image in set B, I am having two pre-images in set A. So -1 is the image of only one element, that is x equal to 0. So the elements in set B are having more than one input elements from set of inputs. Then such functions are said to be many to one functions. Such functions are said to be, here in set A I am having many numbers, and many numbers are uh, pointed to a same image. So we call such functions as many one functions. After completing one and many one function, let's get into the methods to determine whether a given function is one function or a many one function. In order to determine it is one or many one, we have three methods. Those are: one is analytical method, the second one is graphical method, and the third one is differentiation method. So we will go through understanding the analytical method to determine a function is whether one or many one function. First of all, let me take up two sets which are having inputs x1, x2, and so on xn, and the outputs are f of x1, f of x2, and so on f of xn. So if I'm writing a statement, f of x1 is equal to f of x2. F of x1 is equal to f of x2 means when f of x1 and f of x2 both of them are equal, let me mention it is lambda and lambda, and I don't repeat the values in a set. So together I am writing both f of f1, f of x1 and f of x2 as lambda. So whenever the values are different, means the input values are different, x1 and x2 both of them are not equal, means they are different. When they are different, I'm getting f of 1 equal to lambda, sorry, f of x1 equal to lambda, and f of x2 is also equal to lambda. Means for the different pre-images I'm getting a single image. Such functions are said to be the many one functions. Such functions are said to be many one function. But if I take any condition like x1 is equal to x2, f of x1 is equal to f of x2, that is lambda, and let me consider x1 equal to x2, means the given input values are equal. So let me write down x1 is equal to mu and x2 is also equal to mu. Together I can write it is equal to mu. It is equal to mu. So x1 and x2 both of them are equal. I don't repeat the values. That's why I'm simply replacing mu. X1 x2 replaced by mu, and for the single value, for the single output input, I will be getting a single output, that is lambda. Means whenever I'm substituting mu, I'm getting lambda. In the sense, it means the mapping of only one element from set of pre-images is happening to the only one image in set of images, right? So there is only one value, one to one mapping is happening whenever x1 equal to x2 and f of x1 equal to f of x2. So if I want to say this function f of x1 equal to f of x2 and x1 equal to x2, means set of input values equal and at the same time set of output values are also equal. In that case, I can write f of x is an 1 1 function, is an 1 1 function. In all other cases, means f of x1 is equal to f of x2, but x1 is not equal to x2. Means when the input values are not equal but the output values are both of them are equal, so the f of x function is a many one function, many to one function. Means for the same image it is having um, two pre-images in the previous value. So this one is the condition for 1 1 function, and here is the condition for many one function. Here is the condition for many one function. So here is the example number 2. Let me go with example number 2. Define whether the given function f of x equal to x plus 1 divided by x plus 2 is 1 1 function or many one function. In order to say a function is 1 1, if and only if the function, what I've told, 1 1 function is also called with other name, that is injective function, injective function, right? So if I want to say any function f of x is an injective function, therefore it must hold the condition f of x1 is equal to f of x2 if and only if the input values are equal. So let me proceed with this condition first, that is x1 plus 1 divided by x2, sorry, x1 plus 1 divided by x1 plus 2 and x2 plus 1 divided by x2 plus 2. Let me do cross multiplication on both sides so that I can write x1 x2 plus x2 plus 2x1 plus 2. It is equal to x1 x2 plus x1 plus 2x2 plus 2. So I'll cancel x1 x2 and x1 x2 on both sides, and I'm cancelling 2 and 2 on both sides. Let me write down it is 2x1 minus x1 equal to 2x2 minus x2 on right hand side. So I'm getting x1 equal to x2. So where I have started from, I've started my journey from f of x1 is equal to f of x2, and I got the value x1 is equal to x2. Means the given function f of x is 1 function, 1 function. So the next method, that is method number 2, is a graphical method. In this graphical method, we define a function is whether one function or many one function by drawing a horizontal line. We do call that activity, that is drawing an horizontal line, is called as horizontal line test. Horizontal line test. Let's look on to the steps. Let's look on to the steps. Step 1. Step 1. Draw graph of the function within within designated domain, within designated domain. And step 2. Step 2. Draw a horizontal line parallel to x-axis, and where the function is defined, where the function is defined. And the step 3, here we are going to conclude whether the function is 1 or many one. Step 3, if the horizontal line cuts the graph of function only once, then the function is said to be a 1 function, 1 function. And if the horizontal line cuts the graph at more than one place, at more than one point, not one place, more than one point, such functions are called many one functions. So for example, let me take a function f of x equal to x plus 2, and for this x plus 2, let me establish the graph of x plus 2. Let's that one be the x-axis, and here it is the y-axis, and the graph of x plus 2 will be like this, means y equal to x plus 2. Now I am supposed to draw a horizontal line test which is parallel to the x-axis. So the f of x, y equal to x plus 2, is cutting the horizontal line is cutting only once to the y equal to x plus 2. Then I can say f of x is a 1 function, 1 function. And let's say one more equation is given, f of x equal to x square minus 5x plus 6, x square minus 5x plus 6. Here it is the x-axis and here it is the y-axis, and let me draw the graph of this quadratic equation where the roots comes out to be 2 and 3. Roots are 2 and 3. Let me draw a horizontal line test. Where the function f of x is defined, means this function, the horizontal line test, is cutting the function f of x at more than one place, then I could say, I could comment on this quadratic equation, that is f of x is a many one function, is a many one function, many one function. I hope you understood the concept of many one and one function through the graphical approach also. And I want you people to give your opinion or your comment on trigonometric functions like sin x, cos x, and let's say the tan x, and where x values are from minus pi by 2 to pi by 2, and comment on tan x when x values are from minus pi to, sorry, minus 3 pi by 2, minus 3 pi by 2 to 3 pi by 2. So uh, let me tell you within short. So this function, obviously it's going, when you do horizontal line test, it is cutting, the horizontal line test is cutting the sin x curve many times, more than one times. We call this function as many one function, many one function. And cos x also a many one function, cos x also a many one function. When it comes to tan x, in between minus pi by 2 to pi by 2, it is 1 function, 1 function, since the horizontal line test is cutting only once to the tan x curve, and the tan x curve, the horizontal line test cuts more than one point for the tan x curve where the x values are from minus 3 pi by 2 to 3 pi by 2. So I can write the tan x within this domain as many one function, many one function. The last method of uh, determining a function is whether one function or many one function, it is the differentiation method. So within this differentiation method, if you're having f of x, f of x is the curve, f of x is the curve, and wherever you observe whether df divided by dx, is it strictly increasing or strictly decreasing, either strictly increasing or strictly decreasing. At the same time, if it is strictly, sorry, monotonically increasing or monotonically decreasing, monotonically decreasing, such functions, such functions, we call such functions as one functions, one functions. But if none of the things are followed in the above thing, like one at some point, let's say the curve is increase in its slope, and after some time, if you observe the slope of the function is decreasing, means within the same curve there is no continuous increase of slope or no continuous decrease of slope. If there is a change, means increasing is happening and decreasing happening, or the function whose slope is either decreasing first or increasing increasing next, means in this case the function is continuously the function first it get its slope is getting increased and then slope is getting decreased. Mean when you're drawing a horizontal line test, when you're giving a horizontal line test, obviously the horizontal line test is cutting more than at more than one point, means the function will be a many one function when there is increase and decrease of the slopes are happening, or decrease and then increase of slopes are happening. In case number 2, if you recall, when there is a firstly decrease in slope is happening and then there is increase in slope you have observed, then such functions, when you drop a horizontal line test for such functions, you can see the horizontal line is cutting at more than one place. So say these functions are said to be the many one functions. And the last one I didn't included the last method, that is Method 4, Venn diagram. Venn diagram representation. So simply like we know the Venn diagram representation. When there is one-to-one mapping is there, then only you can say the function is 1 1. If in any of the cases, the Venn diagram means the set A and set B, set of domain and set of codomain, if all of them are having one to one or more than one element, it is mapping to the same element, then you can say the function is many one function. Let me write down some properties of the many one and one functions when they are in combinations. We know uh, or plus into plus, any two positive values are multiplicating, we will get a positive value. When two negative values are multiplicating, still we will get a positive value. If one positive value, one negative value, then we will getting negative value, and one negative value first and then positive value next, still we are getting negative value. In the similar way, if you are multiplying or dividing or adding or subtracting to many one function to one function, then you will get a many one function only. And if you are having many one function, multiplication, division, addition or subtraction with a many one function, still the result is many one function itself. And you are having uh, one function is in combination with multiplication or division or addition or subtraction with many one function, still you'll get a many one function itself. The one and only case where you get one function is the combination is both one function, then only you're going to get the one function. This thing you are supposed to remember. Let's say a combined function, that is f of x. It is mentioned f of x1 plus f of x2 and so on f of xn. Let's say n minus 1 1 functions are available. N minus 1 functions are available, and only one many one function many one function is available, then the result of f of x, at least one many one function, if you see in any of the equation, definitely the f of x is going to be a many one function itself. Many one function only. You are supposed to remember, or you're supposed to make a note, or you're supposed to make a comment on this statement. This is a very important statement that you need to remember. So in the present class, what we have discussed till now is the introduction part, in which we have a domain, set of domain and set of codomain, or A is the set of tree image, B is the set of image, and F is maintaining a relation between set A and set B. That is, we are writing it as the function A is a mapping from A to B, where A is the set of inputs and B is the set of outputs. And we had the different properties of the function f. And then later on we have seen types of functions, in which we have list out many number of types of functions, like one function, many one function, many one function, surjective, injective, and then bijective functions, onto function, and then we have into function, trigonometric functions, logarithmic functions, algebraic functions, and some special functions, that is modulus function, greatest integer function, and we have a step function, then signum function, and so on. So in which we had only discussion regarding one and many one function, and for the within the upcoming lectures I would be going to teach you on the rest of the functions and the rest of the parts of the functions, like I'll be going through domain range graphical graphical transformation graphical transformation graphical transformation, and then I'll discuss on functional equations too. Functional equations.